So radical functions, we established, in fact, we can forget about establishments. We'll start sketch as examples. Sketch 1, f of x is equal to root x. Now, when you're sketching this function, obviously you understand that we'll need some values of x for us to find f of x. So suppose x is 0, we'll have f of 0 is equal to 0, since the root of 0 is 0. So we'll get a point there. Then suppose x is 1, we'll have f of 1 is equal to root of 1. Hello?
Sir, I was lost the time you started this, and then you started my sketches, so I'm more lost now.
We started this by sketching. Now we are continuing the sketches. Now what I'm saying is that in case those that we did that day confused you, forget about that day. We have a new day. And this is example 1. Sketch f of x is equal to root x. Now you guys understand that when you're sketching, we used to use tables when we were young. There's no harm in using them today also. X there, y representing f of x. If you try to use a negative number in this table, suppose we use the negative 4, then 0, 1, 4. Let me also put 9. We'll have f of negative 4 will be the square root of negative 4, which is not a real number. Meaning that this is type 1. So type 1. So we'll have f of negative 4 is equal to root of negative 4, which is unknown. Because these functions are real functions. So n squared of a negative number is undefined. So this means that we can only get starting from 0 going this side. So f of 0 is 0. So here at least we have a 0. F of 1 is root 1, which is 1. So we have 1 here. Then f of 4 is root of 4, which is 2. So we have a 2 here. Then f of 9 is the root of 9. Root of 9 is 3. So we have 3 here. So let's see how we fit them. That is 1, 4, 9. So 1, 1 here, 4, 2 here, 9, 3 here. So this graph is going to go like this, like this. That's how type 1 behaves. This is the reason why we said for type 1, the function of this nature, a plus the root of bx plus c, provided that b is positive. You understand that the shape will come out like that. Okay, this is 1a. b, f of x is equal to 2 plus root of x plus 2. Let's see what will happen here. The easiest was that you get x plus 2, you get it to 0, so for x. So you have f of negative 2 This number we get here will give us 2 plus root of negative 2 plus 2, which is 2 plus 0, which is 2. So we have a starting point. What's the starting point? Negative 2, comma 2. Yeah. The only point that we'll need next is the y-intercept at f of 0. This will be 2 plus root of 0 plus 2, giving us 2 plus root 2. For sure, that number is bigger than 2, and we are in type 1, so this is 2 plus root 2.
So kindly repeat what you just said, just the last part.
The last part is that, okay, not just the last part. B, you first need the starting point, which you obtain by getting the inside of the root equal to 0. So for x, the value of x you get, taking the function, you get the corresponding number 2. This forms a point negative 2 for x, 2 for y, the starting point of the graph. Then you get a 0 so that you can know the y-intercept. Since this graph will cross the y-axis, if we didn't want it to cross the y-axis, we still get 0 and substitute in there and see the number that comes out. Now we have gotten 2 plus root 2. This number is bigger than 2. So the graph is type 1. It goes this way. And then we just put that intercept there. All the other points are not necessary to be mentioned.
Okay, thank you.
You must know that in mathematics, we don't you cannot say I've sketched without telling us the intercepts if they are there. Not at all. Very, very dangerous. So every sketch you make, if it crosses the x or y intercept, it must be known where it has crossed. Unless those where you shifted the trigonometric graphs, but then we haven't reached there, so don't worry. I'll give an exception. And you guys, tomorrow, on Saturday, at 18 hours, there will be a test. 1, topic 1. This is the coverage. Topic 2. In full.
That
Abundance.
sorry,
Yes.
some of us recently joined you, so we don't know which one is topic 1. Can you just list them down?
Sets and functions.
Okay, thank you.
When we say functions, we
you.
mean everything. Everything. Radical, absolute, everything. So we are closing this topic. So if we don't finish this tomorrow, we'll have a makeup. So that we finish the functions.
Sir,
You know?
like the questions you sent for me, I sent the solution, but you've not proved to me what I did, if was wrong or not. So I don't know if I'm stable with topic 1 or not. So I don't know how you're going to help me.
So I'm still going through. I think just before this class, I managed to answer about 11. So I was scrolling down. So I will reach you soon.
I hope so, sir.
Yeah, I will. The number is just big sometimes. Okay, next, another example. C f of x is equal to -3 plus the root of 2x plus 6. First thing, we get 2x plus 6 equated to 0. This is 2x is equal to -6. Divide by 2, divide by 2. X is equal to -3. This number is very, very important. It must go in the function. F of -3 will be -3 plus 2 by -3 plus 6. -3 plus root of -6 plus 6. This is -3 plus 0. So we get -3. This number here with that x gives us a starting point, -3 for x, -3 for y. And once you have a starting point, then you can start sketching. -3, -3 here.
Sir,
Hello?
don't forget to record.
Okay, I think we are recording, don't worry.
Okay, twamkunayo bwana.
So this graph is going to, this is type 1 because the inside is positive and the outside is positive, meaning that it's going to go to the right. So let's place where there's x there, we place 0. So we'll have f of 0 is -3 plus root 6. Root 9 is 3. Root 4 is 2. So root 6 is 2 point something. So this number is negative. So this graph is going to go like this, crossing at -3 plus root 6. So what is this intercept here also? So get the whole function.
Sir, kindly repeat.
All right. I'll repeat, guys. You want to know, after having the starting point, you want to know whether you're going to the right or going to the left. The easiest way of knowing is by finding the y-intercept if it exists. So you go where there is x in a function, take 0 there, you get -3 plus root 6. What does it mean? It means that it exists. Now, because root 6 is smaller than 3, bigger than 2, so we'll have -3 plus root 6 will still be a negative number. That's why it has passed down here before it reaches 0. But then it will cross the x-axis. Where? That's where now we're heading to. So we get the whole function. We know that y is 0 on that axis. So now we need to solve for this. 2x plus 6 is equal to 3.
Sorry to take you back. And there where you've written f 0 is equal to -2 plus root 6. Where is that root 6 coming from?
From the whole function. So f is here, is it? Yeah.
Yes, sir.
So since f is here, it is in this f where there's x, we have put a 0. So we've put a 0 here. So 2 times 0 is 0. So we'll have only 6 inside the root. That is a root 6.
Okay, thank you, sir.
Good. So now, when you are looking for the x-axis, for the x-intercept,
Sir,
we are looking at the radical equation now. Yes.
yeah, sorry. Sorry, the network is tripping.
Yeah, we can also tell that it's tripping because the only thing I got is that the network is tripping.
Sir, sir, the
Yeah,
first
I'm kind of
here when you
how you -3 and -3. The other these values the coordinates here. Oh, we going to explain again.
Okay. What's the other question?
sir, me, I'm trying to understand. Like here, you equated this thing to 0 to get the -3. Then what's the
Yeah.
whole point of getting the -3 again and putting it in the function? Why
You
did
want to
do
get
that?
you want to get the value of y at that -3. That -3 is the value of x, is it?
Yes.
So a full point must have x, y. So you're looking for the y, so that you have a point.
Oh, okay. So you can do that before getting the Y-intercept.
Yeah, in fact, not you can. That's what you do.
Always, always. Or just
Always, 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 always.
Thank you.
Sir,
Hello?
what did you say about that -3 plus root of 6?
Plus root of 6.
What did you say about I'm behind?
Okay. And note that the y-intercept is a point obtained by substituting x is equal to 0 in the function f of x. So every time you're looking for the y-intercept, you go to the function f, where there is x, put 0. Meaning you go to the function f, where there is x, put 0. Then evaluate 0 plus 6. So we have -3 plus root 6. The point is called 0, -3 plus root 6. This is the point sketched here. Very, very important. This line, this point here. So take note. To find the x-intercepts, equate f of x to 0. Since y is 0 on the x-axis. So you go to the function f of x and equate it to 0. So what is f of x? It is -3 plus root 2x plus 6 is equal to 0. Take this number the other side, so you have root 2x plus 6 is equal to 3. Then square, so you have 2x plus 6 is equal to 9. Take this the other side, so 2x is equal to 9 minus 6. So 2x is equal to 3. Divide by 2, divide by 2. X is 3 over 2. So this point is 3 over 2. This one here. And the graph is complete. And at this point, when solving for this, what you are doing is you are doing radical equations. When you start doing this is radical equations. So when I say we are done with radical equations, don't say where and how. They have surfaced here. So because you have so many questions, another example. This was C. Now we'll do from type 2.
So can you please bring back the previous board?
So you just took a screenshot. Eh?
So, okay. Thank you.
Sir, you didn't answer my question.
What was your question?
On the -3 plus the root of 6, you said that the root of 4 is 2 and the root of 9 is 3. So does it mean that the root of 6 is between 2 and 3?
Yes.
No.
And
Right.
that's how you get to know whether it's in where that number
So can
falls.
you repeat?
Hello?
I said that. Can you repeat that for square root and
So it is asking that since we said that the root of 4 is 2 and the root of 9 is 3, does it mean that the root of 6 will be in between these guys? So we say 2 will be less than root 6, but it will be less than 3. Meaning that it lies in between there. That's how we estimate the roots. So because there are so many questions, let's do an example coming from here. Example 2, we are still sketching f of x. Now we'll sketch 2 minus the root of x. Now those things I call type. It's like the type was that this has to be plus and the root has to be inside. I think so. The root has to be negative 2x plus 1. So we have it here. What did we say should be our focus? The focus is on negative 2x plus 1. This must be 0, meaning negative 2x should be equal to negative 1 divided by negative 2 divided by negative 2. So x is 1 over 2. This x here, I'm now answering that question which was saying, what happens on this y negative 3 comma negative 3? We answered here. This value we get x is equal to half is the x value for the starting point. Now, we cannot just have x to form a point. We need x comma y. So what will be the y responding to this x? So we get this x and take it in the function so that we get, that is half plus 1. We substitute where there's x. So this will be negative 1 plus 1, giving us 2 plus 0, which is 2. So our starting point is half, comma 2. So now we're about to be done with this sketch. So we have half.
So,
Hello?
yeah.
Hello?
So, you mean that you get the value of x which you have found, not instead what of equating, let's say, what about saying x is equals to 0, then you replace in the same given equation?
That is the
How is that?
that is the y-intercept, and not the
Okay.
starting point.
All right.
So now that we have a starting point, and we don't know where this guy is going, whether it's going up or it's going to the left. Let's see if there's a y-intercept here. So let's get the y-intercept. So f of 0 is 2 plus -2 multiplied by 0 plus 1. This is 2 plus 0 plus 1, which is 2 plus root 1, but root 1 is 1, so we get 2 plus 1, which is 3. This is 2 plus 1, which is 3. So we have a 3 y-intercept, meaning that this guy is going this side. So there will be no x-intercepts. In case you are confused, how do you confirm that there are no x-intercepts? We said to get the x-intercepts, you equate f of x to 0, meaning 2 plus the root of -2x plus 1 is equal to 0. Take this number the other side. We have the root of -2x plus 1 is equal to -2. This thing has never happened. We don't have a positive root equal to a negative number, no. So this cannot happen. That's how we know also.
So,
Hello.
Sam, the same can happen to the y-axis if it doesn't have the y-axis value.
If it doesn't exist, you will notice that when you say 0 inside there will be negative inside the root, meaning no y-intercept. So you can't go to the left, you have to go to the right.
All right, thank you.
Yes. Hello?
Asking if you can write that for me. I'm confused. What you're from saying, just put it in words.
If the root, if the positive root is equal to the negative root, to the negative number, then there is no x-intercept. It's necessary if they are there, Catherine. It's necessary getting them if they are there. But if there's no an intercept, they're not necessary because it's not possible. That's how we get to know that there's no solution here, or there's a solution there, or this is the family. So this was type 2, and I have an example there. So in our next 40 minutes, so this 40 minutes is almost ending. In our next 40 minutes, there will be no radical graphs because the other radical graphs that are remaining, type 3 f of x is example 2 minus maybe x plus 3. And the other type is f of x is equal to maybe -4 minus the root of -x plus 7. These are the types remaining. And you've seen there's no difference in the sketching. You just equate the inside to 0, get that number, substitute in there, look for the y-intercept. If it doesn't exist, then you know you're going to either left or right. Look for the x-intercepts if you're crossing the x-axis. And that's how you sketch them there. So that these two questions here have been called an exercise.
Sir, what
Hello?
about the domain? The domain of that graph.
The domain of the graph. The domain of these functions, remember this is type 2 of the domains where the inside root must be greater or equal to 0.
Sir,
Yeah?
what if the equation inside the root is a quadratic equation? Do you still find the points? Does it mean that you have two starting points?
Yeah, you have two starting points. And we don't necessarily sketch that thing in first year. We do. I saw it somewhere. Don't worry. I'll bring an example.
Hello. What if we force it the same? It will still give us a wrong figure for x. If we force it, before we square both sides.
Yeah, it will give us a wrong figure. When you substitute that figure back, you get a negative root, which is not possible. It doesn't just work. Okay, we're not yet done with radicals. Let's join fast. After we log out, we come back quickly. Then, because I've seen a repeat here about the intercepts, so let's log out and come back. We'll do this, and then we'll explain everything about them. So someone in case I forget, you give me these questions when we log out and come back. So let's come back. Let me just save. Okay.